In our video today, we're going to go through some solution calculations and also how we perform titration experiments. So let's say we're going to do this experiment. We've got some hydrochloric acid, HCl, and sodium hydroxide solution, NaOH, and that forms sodium chloride solution and water. So we take our 0.5 mole per decimeter cubed HCl, and we also have some sodium hydroxide, but we don't know the concentration of that. And the aim of the experiment is to find out that concentration. So I find that when I take 20 centimeters cubed of hydrochloric acid and 25 centimeters cubed of sodium hydroxide, I have a complete reaction. So I now know that the volumes of each solution required to give me a complete reaction and have no HCl or NaOH left over. So let's have a look at the information I have. I know the volume and concentration of hydrochloric acid. I know the volume of sodium hydroxide, and I know the equation. So we can combine this information to find the concentration of sodium hydroxide. So first of all, let's work out the moles of HCl using concentration times volume, and I find I have 0.010 moles of HCl. If I look at the equation now, we can see that for every 1 HCl, I use 1 sodium hydroxide, and therefore I'm going to use the same number of moles of sodium hydroxide as HCl. And so finally, we can work out my concentration of sodium hydroxide, which is the number of moles of 0.01 divided by the volume. And if we go back to the blue box, we remember we use 0.025 decimeters cubed of that. And I can now discover I have got the concentration of sodium hydroxide was 0.40 moles per decimeter cubed. So that's pretty good. We can work out work through those calculations. But how do we actually do the experiment? Well, this is the apparatus that I'm going to need. I need some indicator, a piece of apparatus called a burette, and a pipette. Now, both of those are used for measuring solutions extremely accurately, and also a conical flask to do the reaction in. So let's put these together and find out how we do this experiment, and this is known as a titration. So I take my sodium hydroxide solution and my pipette, and a pipette will accurately measure 25.0 centimeters cubed. So we can pop that in, and if you have a look at the top there with a calibration mark, I need the bottom of the meniscus of the sodium hydroxide solution to be sat on that line. So I extract exactly 25.0 centimeters cubed, and I then deposit that into my conical flask. So I can take my burette and now fill that up with my hydrochloric acid. You can fill it up all the way to the top, and the top is marked at 0, and each division is 0.1 centimeters cubed, which means I can read the volume to the nearest 0.05 centimeters cubed. So we fill it up to the top so that we can make sure that we don't keep having to top it up. So now we pop those bits of apparatus together. I've got my sodium hydroxide in my conical flask, and I've got my hydrochloric acid in the burette. And the burette has a tap at the bottom to let the HCl out very slowly. But how can I tell a reaction has taken place? Because these are both colourless solutions and they're going to form a colourless solution. Well, for that, I need an indicator. And the indicator I'm going to use is called phenolphthalein. Don't worry too much about this, but all you need to know that in acidic conditions, it's colourless, and in alkaline conditions, it's pink. So when I'm going to add that to my sodium hydroxide, it will go pink, and it will slowly pale to colourless as I add hydrochloric acid. And I find that the end point, so that's when the reaction's completed, is when it's a very pale pink colour. If it's gone colourless, you've added too much. So you look for that very pale pink colour to appear. You then record the final burette reading, and let's say my final burette reading is 20.20 centimeters cubed, and I subtract the initial burette reading of 0 from that to find my titer reading. And so that's quite straightforward. The first titer reading is 20.20 centimeters cubed. Now this is normally a bit of a rough estimate, so now we know it's going to take about 20 centimeters cubed to neutralise or to carry out the reaction. so we can repeat the experiment. And we repeat until we obtain two of those titer readings within 0.1 centimeters cubed of each other. So let's say I do that. Those are my two readings that I get. So they are within 0.1 of each other. So I'm going to work out the average of those. And when I work out the average, I find it's 20.00 centimeters cubed. And that's the final result that we used in the calculation at the beginning of the video. So coming up, we'll do some more titration calculations so that you get practice of those. And you can also follow the link to the video which actually shows a practical titration. But please do make yourself familiar with those pieces of apparatus.